When we are old, our joints, they are stressed, and they sorry, let me start again. When we are old, our joints wear and tear more rapidly under stresses than when we are young. Now, materials experience a similar phenomenon called fatigue, where they weaken and fail prematurely under repeated loads. Now, fatigue weakens the material by developing tiny cracks in them, which grow until complete failure. Now, statistics show that more than 80% of the failure in engineering structures like aircrafts, bridges, trains are caused by fatigue, and they often occur without any warning. So it's extremely important for us to know exactly how long the component will remain in service without failing. This duration is called the fatigue life. The material I work with is 300M steel. Now, this material is used for manufacturing aircraft landing gears, the small wheels that support the entire weight of the aircraft during the landing takeoff operations. Now, in psychology, there are two kinds of stresses, positive and negative. The positive stress gives you that boost and helps you improve your performance, like the little guy. And the negative stresses, it undermines your confidence and degrades your performance. Now, in materials, they react in a similar way to mechanical stresses. So compressive stresses increase the performance, while the tensile stresses degrade their performance. Now, the cheapest and the most energy-effective way of producing compressive stresses in materials is by process of shot-peening. Shot-peening is bombarding the material surface with tiny particles called shots, which produce compressive stresses, which stop the cracks and increase their life. Now, all this is really cool, and it increases the fatigue life by 10 times. However, this process has a really limited application because nobody understands the real science behind it. So in my PhD, I'll be conducting tests on specimens with and without shot-peening and comparing their fatigue lives. All these tests will be conducted at stresses that the material actually sees during operation. By all this, we'll make a model that will be able to predict the exact fatigue life of the component without even having to test it. This will revolutionize the design of all engineering structures and make them a lot safer. Thank you.